Hi, welcome to session 8. So this session is all about surface area. I'm going to do a quick recap, so a quick refresher of our basic areas, just to make sure that we have that knowledge secure. We should do at this level, because this is a kind of grade 3 workout, whereas what we're going to move into are our 3D shapes, which is taking it up through the levels. But we need these key skills if we're going to do it. So it's not going to be the normal recap. I don't do that after a consolidation session anyway, because they're quite intense. And we've just done a big chunk of revision on that. So it's nice to just crack on with something different, I think, following one of those. So what I want you to do is hit pause and have a go at those 3 questions, and then play when you're ready, and we'll look at the answers. Okay, so there's the answers. So first thing is area of a triangle, base times height divided by 2. How do I know which one out of the 3 to use? Now, if that's something that you're not sure about, it's here in the right angle. It's such a nifty, easy little trick to remember as well. If you just put arrowheads onto your right angles, it points to the 2 edges you have to use. So it doesn't matter if they give you a question which is like upside down and back to front. You know, I could try and make that 5 the base, and then you automatically want to use that. So it's all about the right angle. The right angle will point to the 2 edges. And then obviously we just need to be remembering to half for a triangle. Area of a parallelogram is exactly the same to a rectangle, because it's basically a rectangle that someone's just gone whoop, and sort of squashed over, but the area inside remains. So that is just base times height. And then these style questions are where they're putting 2 shapes together. We don't have a formula for L shapes, so we break it up. You may have broken it in this direction, and therefore your workings out will be slightly different, but your end answer should be the same. Okay, and that is obviously centimeters squared as well. So those are some of the basic shapes that we should already be very secure with. Okay, so we're going to look at this. These are 2 shapes. They've got the same name, even though they look a little different to each other. Can you name the shape? All right, they are trapezium. Okay, this is a trapezium. It's got 1 set of parallel sides, and so does this. So you have a set of parallel sides, and then the other 2 sides, it doesn't matter whether they're doing this, 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 as long as they're not doing that, because then you'd have a rectangle, or that, because then you'd have a parallelogram. But as soon as one changes, then you've got your trapezium, okay? Now, trapezium has its own formula, but you can, on occasion, get away with not using it. So this is an example of where we could get away with not actually using it, because if I split the shape here, then I've got a rectangle and a triangle. So I can say, right, the area of my rectangle, which is base times height, is 5 times 5, which is 25. And the area of my triangle is base times height divided by 2. So that is going to be this here. Here's my right angle. So there's my 2 edges. That's going to be 2. 7 take 5 is 2. So I've got 2 times 5 divided by 2, which is 5. So the area of my trapezium is 30 centimeters squared. And I'm just using prior knowledge of rectangles and triangles. I don't need that additional formula, so I don't use it. But it's a bit of a trap to fall in, because if you think you can just get away with not worrying about that formula, the chances are they're going to give you a question that requires the use of it. And then if you don't have it available to draw from your memory because you've relied on this sort of split method, it's just not going to help you, is it? So we are going to learn the formula and we're going to apply it all the time, even if we can get away with not using it, so that we become confident with it. Okay, so this question here, which again is a trapezium, we want to find the area of. If I was to do the split system, I'm just going to show you why it's important. I would end up with 3 different calculations to do, 2 triangles and a rectangle. So that straight away is opening me up to making errors. It's easy to be working away and then accidentally make a mistake as you go. And 3 different shapes to find the area of is starting to get quite a lot. So the other reason is, okay, I know that edge there is 3, but I do not know these. I can guess that that could be 1 and that could be 4. But I'm guessing, and we don't guess in maths, that can't be encouraged as a good idea. So the formula is going to be the thing I want to use here. So I need to know it. So let's just clean that up. What I'm going to do is I'm going to do the formula on both. And I want you to watch how I use the numbers from the diagrams, okay? So if I'm going to do the formula for this first one, I would do 5 plus 7. I times that through by 5. So I'm just squashing it in. 5 plus 7 is 12. 12 fives are 60. And 60 divided by 2 is 30. Exact same answer, which is obviously what we would expect. So if I'm going to do the same with this one, I am going to do 3 plus 7. I am going to times by 2, divide by 2. 3 plus 7 is 10. When I times by 2, it's 20. When I divide by 2, I take it back to 10. So that is 10 centimeters squared. And you can see that is not a massive amount of work. Doing the 3 different shapes, 2 triangles and a rectangle, that would have been a lot of work. That is not. So again, a really nice reason to learn this formula. So what I want you to do is I want you to pause and just think about the numbers that I used and how that formula might be written, okay? So area of a rectangle, base times height. Area of a triangle, base times height. So if I'm doing the area of a trapezium, what would the formula actually be? Can you have a go? Just see what you think it is and then hit play and I will tell you. Okay, so the 3 and the 7 are there, and the 5 and the 7 are there. So what you might have written was add top and bottom. That would be a sensible thing to write when you're not really sure how to write it, okay? Or you might have said add the parallel side, which is even more accurate, because that is what we do. We add the parallel sides. Obviously, we're not going to be able to write all of that in a formula, so we just write A plus B. And A and B, adding that is our first step. We must make that total before we multiply, so we put it in brackets. So what you could do is just pop your parallel line signs above that bit to help prompt and remind you that that's what I'm adding, the parallel lines. Again, really important, because I could easily just take this and I could give it to you like that. Well, suddenly, I'm going to leave that one like that. Suddenly, that doesn't look like top and bottom, does it? So you don't want to learn it like that. It's parallel sides, A and B, absolutely, okay? So the next step is to times through by the height, okay? I multiplied by 5, which was there. And I multiplied by 2, which was over here. So actually, I am going to have to take this back just to show you that, okay? So that makes the right angle. If I move this now into the inside of the shape, rather than having it as an arrow on the outside, you can really easily see that right angle. Okay, and that height is always attached to the right angle, absolutely always. One of the things that I say in class is you've got, and I'm doing it in red now, you've got H for height, and that right angle helps create the H for height. So they're all little gimmicky things, but they're things that might help you remember. Okay, so you times through by the height, and then you divide by 2. So I'll put that in a little bubble. That is the trapezium formula. So it's a little bit bigger than your triangle and your rectangle, but not massive to the point where you can't remember. How do you remember to divide by 2? Well, it is the same as the last step of a triangle, and a trapezium always has a triangle at some point, if not twice, in their picture, in their diagram. So that might be the prompt that helps you as well. Okay, so there's lots of top tips about that trapezium. So before I leave you with a little bit of practice, we're going to look at a slightly different question. And again, one that makes knowing the formula so incredibly important. If I was relying on splitting shapes, I wouldn't be able to answer this question very easily at all. Okay, so what I want you to do is I want you to write out, in fact, I'll do it with you. Okay, so the area of our trapezium is A plus B times by the height divided by 2. Now, what I want you to do is take the information that you've been given in that question and put it into the formula and see if you can then manipulate what you've got to finding the answer for the edge of the height. That's what we want to work out. What does that height equal? Now, we've got everything we need. We've just got to know how to use it. So please pause, play around with this. It's a really important part of learning maths, having a go and just seeing what you can do, and then come back and I'll show you how it's done. Okay, so I know that A and B are the parallel sides. So I know that I can put 5 plus 9 here. I know that that will be multiplied by the height, a number I don't know, so I'm just going to leave H in the formula. I know the whole thing is going to be divided by 2. And when that happens, I know it's going to equal 42. Okay, I know it's going to equal 42 because they told me in the question. So now I'm back into the world of equations. If I want to know what H equals, I've got to get it on its own. So I'm going to tidy the 5 and the 9 up, and I'm going to write, I've got 14H divided by 2, which is going to equal 42. Okay. I am going to dig the divide by 2, hop it to the other side where it will land as times by 2. 42 times by 2 is 84. So I've now got 14H equaling 84. Okay. Take the times, 14, it lands as divide 14, and then 84 divided by 14 is 6. So H is equal to 6, or 6 centimeters, because it's actually got a unit of measure as well. So that's using the, and you'll do that when you have to find a missing edge of a triangle in a similar way. You use the formula, you're going to end up with a letter, and you've got to work it through so that you get that letter on its own and you find out what it equals. Okay, so I've thrown that in as a bit of an extra thing for you to think about as well. Okay, so this is just 5 questions, so nothing too major, for you to just practice those skills. You know, trapezium's obviously in there to get on with the formulas, and just some different kind of ways that they can word questions to make you think a little bit harder about it. Just going to minimize myself so that you can see all those questions. So you're going to hit pause, have a go, press play, the answers will obviously come up, and then just move between them. Don't do all 5 and then mark, do a couple, mark, and so on. And then we'll start working on that surface area. So I'm just going to bring the answers up. Okay, so surface area, the main part of this, okay? We've got a triangular prism, and if we're going to find the surface area, it means that we've got to find the area of all the faces. And I'm hoping that I'm going to be able to use some colour to help you sort of see every step that we're going to do. So to start off with, I am going to just find the very front face. So the triangle at the front is identical to the triangle at the back. So I'm going to work out those two to start off with. So my front is the area of a triangle. So it's going to be 5 times 6 divided by 2, which is 15. And then the back is going to be 15 as well. Okay, so that's my front and my back. All right. Now, all the faces around the prism, okay, so you've got the front, you've got the back, and then you've got all of the ones around the sides. They all come from an edge at the front. And I'm going to show you, hopefully, like I say, with colour that makes this pop out. So if I just look at the very base of our shape, so just looking at the base, you can see that it's obviously a rectangle, and the 2 edges that make the rectangle is that part and this part. So you've got like the 2D shape of the triangle, and then this length here is what creates some depth to it and therefore creates the 3D shape. So I kind of call this the third length. This changes it from a flat 2D triangle to a prism. Okay, and I call that, like I say, the third length. So this edge is going to get multiplied by this third length here. So the base is 6 times 8, which is 48. Okay, now let's take a look at the sloping side here. It is another rectangle. This rectangle is coming from the 2D triangle and the third length. So we'll call it slope. I am going to be using 7.8, timesing it by 8, which is 62.4. And then last but not least, I have got my vertical side here, which I'm hoping we can see what's going on here. That's coming off of that edge and then going back by the third length. So the side, I'll just call that side, is 5 times 8, which is 40. So now I've got the front, the back, I've got all the sides around the middle. I just have to add all of those together. So I've got 15 plus 15, so I've got the 30 plus 48 plus 62.4 plus 40, which is giving me 180.4 centimeters squared, because it's area. So this is the key that I'm hoping you've picked up. Every edge of the front face is used by the third length. So the bottom, the sloping, and the side, all 3 edges of the front are used with the third length to find it. So you could make a note that to find the surface area, you find the front and the back, and then all edges of front multiplied by the third length. And that is true no matter what shape you're looking at. You know, the prism, we've got a different prism in a minute, so we'll see that working again. And that is surface area. That is a way to approach it that makes sure you don't miss any of the faces off and you get all the information that you need. Okay, so here we have got, oh, let's just take it down a little bit. We've got our trapezium prism. So we've been given a trapezium as our front face. And then obviously we've got all those edges that grow off of that front face, don't we? So the first job is to find the area of the front and the back. So the front, I was going to write front in full then, just get rid of that, there we go. So the front is going to be the parallel side, so this plus this, 4 plus 10, times by the height, which is given over here, and then divide that by 2. That is going to give me 21, which means the back is 21. So I've got my front and my back. Now, every single edge, okay? So I'm going to just show it again with a little bit of color. There is my base, which is going to be base by how far back it goes, okay? There is my side, which is that edge times by the third edge. That is the same on this side as well, because they've got the same number. I've got a 5 on that slope. I've got a 5 on that slope. So that will save me a little bit of time spotting that. And then obviously I've got my top, which is this edge. So every single edge in turn is used, okay? So I'll just get rid of that now so we've got some space to work in. So I am going to do the base or the bottom, which is going to be 10 times 6. It's a rectangle. 10 times 6 is 60. And then going to do the side, which is 5 times 6, which is 30. And obviously the other side is 30 as well. And now I'm going to do the top, which is 4 times 6, which is 24. And then I'm going to add all of that together. So I've got the 42 front and back, plus the 60, 30, 30, and 24, which is going to give me 186 centimeters squared. So exact same approach as the triangle prism, front and back, and then this edge times back, this edge times back, this edge times back, this edge times back. So timesing by that third length every time, okay? All right, that is, let me clean this off. There is another one that I just wanted to just mention. There's no numbers. We're not actually going to do this, but we are seeing this sort of shape coming up for our area, surface area, and our volume. And it's obviously a couple of cuboids that have been stuck together. But what I want to show you is that there is a bit of a shortcut that you can take, because if you think about it, that edge, that face, that face, that face, the base, this side over here, there is masses of work to do on a question like this. But the reality is there isn't as much as it first looks. So if I say to you, I'm looking at the base of a rectangle. So I'm going to use this to show the base of my rectangle. Okay. The base of that rectangle is absolutely the same as the top. So here is the base of the entire L shape. The top is the same as the base. It's just somebody has said, okay, here is the base, and we're going to bring up a rectangle. So the base is growing together. And then they said, oh no, we're going to stop and just keep going that side. So together, it's the same thing. And then suddenly it splits. But the top of that and the top of that is still, if I was to crush it down to the ground, it would flatten into the space of the base. So they are identical. So I don't need to be working out this and this separately. I can literally find the base and double it. Exactly what I would do here. Find the base and double it. Nothing is different. And it's absolutely true of the side as well. If I take the side here, okay, and then consider squashing into, just crushing that shape and squashing into the side, this side and this side would meet, and it would actually be the same. So it's like somebody's taken the side, grown it out, and then taken that one on a bit further. So once I found one side, I can just double it to find the other and not work on every single individual face. And then obviously the front is the same as the back. So in this, it's just the rectangle doubled. Here, you would have to find the L shape, and then you would double that. So the numbers aren't there because I'm going to allow you an opportunity to just work through one of those without it being 100% demonstrated, you know, to help with your building of confidence and stuff. But I did want to show you the shortcut so that you didn't waste time doing loads and loads of additional work that you don't need to. So hopefully that has helped and it has made sense. Okay. All right, let's move on to your worksheet. Now, what I've done, you will see, this is something you can print. All right, I'll zoom back in case you want to just work from the screen. And obviously I'll do the same for the answers in a moment. But this is your worksheet for you to play around with, okay? So you've got the first part where you have just been given the prisms. So remember, your formula is just find the front and the back and then do your edges. Be careful with this. I've given you the hint and the shortcut. And then I've gone into doing some sort of wordy questions. So it's all still surface area. It's all application of what we are learning. And I think it's really, really important to combine the two. So this technically is extending you, but don't be looking at that as much harder. The top tip that I would give here is if you've got a fully worded question and you have no diagram to work against, draw one, make your own diagram. We are really good at processing with a diagram involved. So the minute they take it out, it's much, much harder to deal with it. So no, the examiner is kind of expecting you to draw your own diagram because it would be the way to get into the problem. So make sure that you do that as well. Okay, so I am going to disappear and we're going to zoom in on this so you can see everything nice and clearly. So I'll just go through slowly. I'll do the same with the answers and then I will see you next session. Next bit.